well, back for Unit 3. We're just going to do this one in this video, and then I'm going to do a separate video for Unit 4 because they take a little longer. But this should be pretty fresh in your memory. It's transformational geometry, transformations really, and we just finished this up before we left. So it says, find the coordinates for the and graph the image of quadrilateral after a dilation. Okay, so we know a dilation about the origin with a scale factor of 1/2. Okay, 1/2 is less than 1, so it's going to make things smaller. So basically what you need to do is you're going to cut all these coordinates in half. So you don't have to do this, but I like to write down the coordinates. So x is 0, 2. So if I cut it in half, oops, my pen is down. So let's try to use this one. Sorry, guys. 0, 2. So if you cut it in half, x prime would be 0, 1. So, okay, 0, 1 would be right there. So there's x prime. And then I do the same thing. Y is located at 4, 2. So if I cut it in half, y prime would be 2, 1. So 2, 1 makes it right there. There's y prime. And then I'm going around clockwise. So z is at 4, negative 1. So z prime would be at 2, negative 1/2, or 0.5. So 2, negative 1/2 would be right there. So there's y, or z prime. And finally, w is located at negative 2, negative 1. So w prime, if I cut that in half, would be negative 1, negative 0.5. So negative 1, negative 0.5 puts it right there. There's w prime. And then don't forget to connect it so you can see it's the same shape. It's just half the size, smaller. Okay, now it does say, and let me use another color for this, if the image, which is our after, remember this is the image, all these coordinates, was rotated 90 degrees clockwise. So they want you to take the small one and rotate it 90 degrees clockwise. What would the coordinates be of just x double prime? Okay, so if you remember 90 degrees clockwise, I know I use the hand rule a lot on you guys, but your clockwise hand, if you put your hands up that corny way we used to do, is the one that goes clockwise. All right, so what happens is, remember that coordinate leaps and negates. So that means the y comes up front and it's negative x. Negate means make it the opposite. So if I have the point for x, which is 0, 1, okay, and I follow that rule, so that's x prime, x double prime then would be, leap it over, 1 would come up front, and the negation of 0 is still 0. So actually it would be right there, which makes sense because if I put it on there, I won't do the whole thing, but you can see the 90-degree angle it makes with the center right there. So that's what it would be, okay? All right, number 13. If I look at number 13 says that the single prime triangle is the dilation of that. Find the scale factor. Okay, so it looks like it got bigger. So then the question says, is it an enlargement or a reduction? It's definitely an enlargement because it's stretched out. So when I look at it, the original length of it was 4, but now remember the new length is not 2, it's actually 6. So when I think about what the scale factor is, it would be 6 divided by 4 is 1.5. So it's 1.5 times bigger. Okay, so that's all I had to do for that one. Pretty easy. Okay. Next page, page 6. Okay, you guys are good at these. This should not be any trouble at all. It says to translate, which means slide. Don't forget, you're sliding things around the graph. And if it's negative 2, left 2, and up 4. So that's what you're going to do. Left 2, up 4. So again, I just start with x. Since I have the grid, I'm just going to count it out. 1, 2, 1, 2, 3, 4. There's x prime. All right, w, 1, 2, 1, 2, 3, 4. W prime. Z, 1, 2, 1, 2, 3, 4. Z prime, and 1, 2, 1, 2, 3, 4. Y prime. Now again, when you connect the dots, and don't forget to do that, you will notice this is congruent to the original. It does not get bigger or smaller, it just slides. Left 2 and up 4. So there it is. Okay, number 15 says, let's do a reflection across the dotted line. Okay, well, this is a vertical line, and just because I like to throw in extra math, what is the equation of this line? Well, if it's vertical, it's a vux, which means it's an x line. And what does x equal every time? X equals -2. So that's actually the line you're going over. But you don't really need to know that as far as drawing it in the right correction. If it says to reflect it over the dotted line, you look at W and you say, okay, well, W is 2 to the right, so W prime has to be 2 to the left. It's the opposite of it. Same level, but other side. And X is, if I count it, 1, 2, 3, 4 to the right, so I go 1, 2, 3, 4 to the left of that line. So there's X prime. W also is 4 to, or I'm sorry, Y is also 4 to the right. So go backwards, 1, 2, 3, 4 to the left. There's Y prime. And Z is 2 to the right. So again, 2 to the left. And there is Z prime. There it is. So mirror image, you fold it on that dotted line, it would all line up. And it looks good. Okay. Last one for today on Unit 3 is refer to the grid below. Describe how you could move shape 1 to exactly match shape 2 by using one translation and one reflection. Okay, so first of all, if I look at shape 1, I need to get it upside down. So my first move is going to be to use a reflection first. So I'm going to reflect it over, what is this axis? The x-axis. That's my first move. If I do that, it's up 1, it would be down 1. That's up 2 right there. That would be down 2, up 1, down 1. So going upside down, it's going to look like that. Where's that point 3 above that? So 1, 2, 3 right there. And the same one there, 1, 2, 3. So I can pretty much, and then 1, 2, 3, 4. 1, 2, 3, 4. So I can draw it upside down. Looks going to look like that. So now my only other goal is I need to slide it over into place. So if I just look at this dot, that would be the same as this dot here. So I have to count how far would I go. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3. So I would say that I'm going to translate right 12 and down 3, which again, more math in coordinate notation would be x, y arrow, x plus 12, y minus 3. And that's it. Okay, I'll come back and post another video for Unit 4 tomorrow. Okay, take care.